Good morning, everyone. I am LEILANE PACAñA, and I am assigned to the topic Linear Programming Simplex Maximization Method containing less than symbol. So, this is my topic in my reporting on our subject, Mathematics in a Modern World. Good morning, ma'am. And now, let us proceed to our discussion. First, let us determine what is simplex maximization method. First, going down to its history, it was developed in 1948, and the mathematician who discovered it was George Dantzig. So he was able to formulate this kind of method in solving linear programming problem. Now, what is simplex method and how do we use it? It provides us with a systematic way of examining the vertices of a feasible region to determine the optimal value of the objective function. So actually, simplex method can be used in linear programming problem wherein there are linear objective function in which we will be maximizing it. In this problem, we are taking the maximization. Now, we will maximize it to certain constraints in order to determine the optimal solution or if there is an existing optimal solution for this particular linear programming problem. Now, simplex method is also used for problems in linear programming that consist of two or more decision variables. So that is how advantageous is the simplex maximization method. And that is because in linear programming problem, simplex method is not only the method that can be used in solving it. There are other methods. However, simplex method is advantageous because it can solve problems that has two or more decision variables because unlike for the graphical method, it only take two variables. Now, simplex maximization method is an iterative process wherein the iteration will stop when an optimal solution is already reached. So what do we mean by iteration? Iteration is a repetitive process of a mathematical computation in order to determine the approximate solution for that kind of problem. So there is a repetitive process in simplex method, and that will occur in our table as we will discuss it later. Now, there are different terms that we can discover in our simplex method in applying it to our linear programming problem. Now, first, we have the initial simplex tableau. This is used to perform raw operations on the linear programming model as well as for checking optimality. So this is a table wherein we can find our constraints, our variables in which our simplex method will actually be performed. And now, there are also what we call the entering and the departing variable. So what do we mean by entering variable? It is a variable where we can find it in the most negative entry in the bottom row of the variable. And then the departing variable, we can find it as this in the row wherein the smallest non-negative ratio of the column determined by the entering variable. So we can check or we can discover these variables later in our discussion. Now, there is also one of the most important step in our simplex method, which is the pivoting. So in pivoting, we can determine the pivot element, the pivot column, and the pivot row. So how do we determine the pivot element? It is actually the number wherein the pivot row and the pivot column intersect. So to where they intersect, that is our pivot element. So how do we determine our pivot column? It is the column where the most negative entry in the bottom row variable is located. So later on, we will be discovering the most negative entry and discovering what is our pivot column. Our pivot row is the row where the smallest non-negative ratio is located. So later on, we will perform this in order to determine this pivot element, pivot column, and the pivot row. So there are steps in solving linear programming problem using the simplex method. First is, as we already create our linear inequalities by using the less than symbol, we will transform objective function and the constraints into a system of linear equations. And there is what we call the slack variables, which we will be applying or we will be adding to our constraints. The step 2 is to set up our initial simplex tableau. And next, we will determine the pivot column, the pivot element, and the pivot row. So this is where the pivoting will occur, in which we will transform all entries in the pivot column to be 0 except for our pivot element. So that is how simplex method will be performed. Now, the step 4 is to repeat the step 3 using the new table until there is no negative entry in the last row anymore. So one of the most important consideration here is to look at our bottom row, and if there is no negative entry anymore, then we have already reached our optimal solution. Now, to really determine or to really understand how simplex method will be used, then I have 3 word problems in order to determine or to understand how this works and to try how linear programming problems can be solved by using the simplex maximization method in the application of less than symbol. So now let's have our first word problem. So here it goes. Shine Company produces 3 types of glass windows. There are 3 departments using advanced machine and equipment to complete each type. Type A requires 10 minutes of melting and refining, 15 minutes of cutting, and 8 minutes of quality check and packaging. Type B requires 12 minutes of melting and refining, 14 minutes of cutting, and 6 minutes of quality check and packaging. Type C requires 12 minutes of melting and refining, 20 minutes of cutting, and 8 minutes of quality check and refining. The time allotted every week for melting and refining is 1,500 minutes, 1,000 minutes for cutting, and 800 minutes for quality check and packaging. Suppose a profit for each glass generates 20, 30, and 50 respectively. How many types should be produced to obtain a maximum profit? So now we will have to know what will be the number of these types of glass windows in order to reach that maximum profit, and what is their maximum profit. So now we'll have to make an inequality or linear inequality because we are taking the less than symbol. But first, let us use variables for our inequality. Let x sub 1 the number of type A glass windows, let x sub 2 the number of type B glass windows, and let x sub 3 the number of type C glass windows. So we will use that in our mathematical expression or mathematical inequality. Now first, we have our objective function. We will maximize this. This is our profit. So it's z is equal to 20x sub 1 plus 30x sub 2 plus 50x sub 3. So those are the profit that we can obtain in each glass windows in our problem earlier. Now it is subject to these are the constraints, and it is an inequality because, as I have said, we are taking the less than symbol in our simplex maximization method here. So now let's has our first constraint. 10x sub 1 plus 12x sub 2 plus 12x sub 3 is less than or equal to 1,500. So this is for our first department in order to create that glass window. So for our second constraint, it's 15x sub 1 plus 14x sub 2 plus 20x sub 3 less than or equal to 1,000. So this is for our second department, which is the cutting department. Now for our third, 8x sub 1 plus 6x sub 2 plus 8x sub 3 is less than or equal to 800. Now, as you can see, in our right-hand side, those are the number of minutes allotted for those departments. And for our left-hand side, those are our constants. So now, we will assume that x sub 1 and x sub 2, x sub 3 is greater than or equal to 0. Now, our first step, as I have stated earlier, is to make those inequality into a linear equation. Since we are using the less than symbol in maximizing, now we will be having an equality in order to perform the simplex maximization method. So for our objective function, from our right-hand side, we have to transfer it to our left-hand side. So how do we do that? We have to change its sign. So from our right-hand side, since it was positive earlier, as you can observe, we have to make it negative as it transferred to another side. So it would be negative 20x sub 1 minus 30x sub 2 minus 50x sub 3 plus z. That is our profit. And it is equal to 0. So to make it equal to 0, we have to transfer it. Now, for our constraint, we have to make it an equality. Now, how do we do that? We have to add slack variables. So these are the slack variables that will fill this inequality to make it a linear equation. So in less than symbol, we really have to add slack variables in order to transform this inequality into linear equations. Now, for our first constraint, it would be 10x sub 1 plus 12x sub 2 plus 12x sub 3 plus s. Our s here denotes or it represents our first slack variable, and it is equal to 1,500. For our second constraint, it's 15x sub 1 plus 14x sub 2 plus 20x sub 3 plus t. Our t here is our second slack variable. We cannot use the first slack variable because it is intended for our first constraint. So now we will be using t. The letter t here is our second variable or slack variable, and it is equal to 1,000. And for our third constraint, it's 8x sub 1 plus 6x sub 2 plus 8x sub 3 plus u. Our u here is our third slack variable because actually we can use letters or these variables, for example, s, t, u as the slack variable. So u here is our third slack variable for our third constraint. And it is equal to 800. So now we have linear equations. Next is to make an initial simplex tableau. So how do we do this? We have to put all of those linear equations to this table. That's simple. So we just have to put it all in this table. From our left column, these are the basic variables. We have the S, T, U, and our Z. These are the slack variables and for our profit. Now, for our top, these are x sub 1, x sub 2, x sub 3, S, T, U, Z, and our right-hand side. As you can observe, our right-hand side, these are the number of minutes. You just have to put it all. So, for our first constraint, we have 10, x sub 1, 12, x sub 2, 12, x sub 3, and we have, as I have stated earlier, as we can observe, our first constraint, there is one slack variable. So there's one. We don't have the second and third and the z or the profit. So just put 0. For our second constraint, of course, we have 15, 14, 20, 0 as our first slack variable. We don't have that, but we have the second slack variable for this constraint. So let's put 1, 0 for the third slack variable, and 0 for our profit. And it is, of course, equal to 1,000. As we have observed earlier, so just put 1,000 there. And u, it is equal to 8 x sub 1, 6 x sub 2, 8 x sub 3, 0 for our first and second slack variable, but it has 1 for our third slack variable, as observed in the linear equation earlier, and 0 for our z, because we don't have that for our third constraint, and it is equal to 800. Now, for our bottom row, this is one of the most important part in our table or now tableau. This is for our profit. Now, we just have to put it as well. So, it's negative 20 for x sub 1, negative 30 x sub 2, negative 50 x sub 3. We don't have the 3 slack variables, so we'll just put 0, but we have our z here, so we'll put 1. So now we have to determine our pivot column, the pivot row, and the pivot element. So how do we do that? First is we have to determine our pivot column first. So how do we determine our pivot column? The most negative entry in the bottom row from our profit, that is where our pivot column can be found. So what is the most negative entry here? Of course, that is negative 50. So the column where negative 50 is located, that is our pivot column now. And then for the second one, we have to determine our pivot row. How do we determine our pivot row? So we have to determine the smallest positive quotient by dividing right-hand side by our pivot column, the x sub 3 column, as you can observe. So 1,500, we have to divide it by 12. So that is 125. 1,000 divided by 20, that is 50. 800, divided by 8, that is 100. So what is the smallest positive quotient here? Of course, that is 50. So the row where the 50 is located, that will now be our pivot row. So we have now our pivot column and the pivot row. How do we determine our pivot element? So our pivot element can be found as to where the pivot column and the pivot row intersect. So as you can observe in our table, it is on the number 20. So our 20 here is the pivot element. Now, one of the most important consideration in our pivot element is that it should always be equal to 1. So as you can observe, 20 is not equal to 1. So we have to make it equal to 1. How do we do that? To make 20 equal to 1, we have to divide it by itself. But the whole pivot row will be affected to that. So here is it. As the whole pivot row is affected. So of course, we have to divide the whole row by 20. So 15 divided by 20, that is 3/4. 14 divided by 20, that is 7/10. 20 divided by 20, we have now 1. 0 divided by 20, of course, 0. 1 divided by 20 is equal to 1/20. 0 divided by 20 is equal to 0. 0 divided by 20 is equal to 0. And 1,000 divided by 20, we have 50. Now, these results, the 3/4, 7/10, 1, 0, 1/20, 0, 0, and 50, that will now be our new pivot row because we have to make sure that our pivot element is always equal to 1. So as you can see in our second row, that is our pivot row, we have our new pivot row already. Now, one of the most important thing we have to look at is our entering and our leaving variable. So our entering variable is on our pivot column. The variable on our pivot column, of course, that is x sub 3. And our leaving variable is t. It's where the pivot row is located. So the x sub 3 will replace our t in the basic variables. And now, we have to make all the entries in the pivot column equal to 0. As you can see, we have 12, 8, and -50. How do we do that equal to 0? So first, for our first row, in order to make 12 as equal to 0, we have to add -12 for that. And how do we do that? Of course, we have to multiply the pivot row by -12. First, so we'll multiply it. -12 times 3/4, that's -9. -12 times 7/10, that's -42/5. -12 times 1, that's -12. -12 times 0, it's 0. -12 times 1/20, that is -3/5. -12 times 0, it's 0. -12 times 0 is 0. And -12 times 50, that is -600. So those results, we have to add it to our previous entry in our row 1. So to add that, our previous entry are 10, 12, 12, 1, 0, 0, and 1,500, as you can see. And we have to add our product. So 10 plus -9, that's 1. 12 plus -42/5, that's 18/5. 12 plus -12, we have 0. 1 plus 0 is 1. 0 plus -3/5 is -3/5. 0 plus 0 is 0. 0 plus 0 is 0. And 1,500 plus -600, that is +900. So that will be our new row 1 now. So you can observe, we have put it there. And now, as you can see, our 8, we have to make it equal to 0. How do we make that equal to 0? We have to add -8 for that. And we'll just do the same thing again. We have to multiply -8 to our pivot row. So -8 times 3/4, that is -6. -8 times 7/10, that is 28/5. And -8 times 1 is -8. -8 times 0 is 0. -8 times 1/20, that is -2/5. -8 times 0 is 0. -8 times 0 is 0. And -8 times 50 is -50. 400. So that result, we have to add it to our previous row 3. So to add 8 plus negative 6, that is positive 2. 6 plus negative 28 over 5, that is positive 2 over 5. Negative 8 or positive 8 plus negative 8, we have 0. And 0 plus 0 is 0. 0 plus negative 2 over 5, that is negative 2 over 5. 1 plus 0, we have 1. 0 plus 0 is 0. And 800 plus negative 400, we have positive 400. So that will be our new row 3 now. So we have to put it to our initial simplex tableau. Now we only have one number to make it 0, that is negative 50. How do we do it? We have to add positive 50 for that, and we have to do the same process again. So now we have to multiply 50 to our 5th row. So 50 times 3 over 4, that is 75 over 2. 50 times 7 over 10, that is 35. 50 times 1 is 50. 50 times 0 is 0. 50 times 1 over 20, that is 5 over 2. 50 times 0 is 0. 50 times 0 is 0. And 50 times positive 50, that is positive 2,500. So that results now, that will be what we will add to our previous row 4. So to add, negative 20 plus 75 over 2, that is positive 35 over 2. Negative 30 plus 35, that is positive 5. Negative 50 plus positive 50, of course, that is 0. 0 plus 0 is 0. 0 plus 5 over 2, that is 5 over 2. 0 plus 0 is 0. And 1 plus 0 is 1, of course. And 2,500 will be bring down here. So that result will now be our new row 4, as you can observe in our table now. So you just have to put it all there. As you can observe, 35 over 2, 5, 0, 0, 5 over 2, 0, 1, and 2,500. So now you have to observe our pivot column. Is there other number here that's not 0? And of course, the 1 as our pivot element, of course, not anymore, because all of the entries in the pivot column are 0. So now you have to observe the bottom row, or on our profit. Is there still a negative entry? As you can observe, there is none, because all of them are in positive sign. So that means we have already reached our maximum or the optimal solution. Now we just have to interpret it. Looking at our basic variables in our right hand side, S is equal to 900, our X sub G is equal to 50, our U is equal to 400, and our Z here is equal to 2,500. So now we just have to interpret it. Now our X sub G is 50, our T, or the second slack variable, is 0, because of course we don't have T here in our basic variables. We have U, the third variable, as 400. And our Z is 2,500. Our X sub 1, we don't have X sub 1 here, so that's 0. Our S is 900. And our X sub 2 is, of course, 0 as well. So we will substitute it to our linear equations earlier to see if we have a correct answer, or we have obtained the correct solution. So how do we interpret it? So we just have to put or to substitute all of our values. So 10 times 0, because we don't have X sub 1, that's 0, plus 12 times 0, because we don't have X sub 2, plus 12 times 50, because we have X sub 3, plus 900, that's 1,500. 900 here is the unused minutes that we have in our company, or the company, because slack variables means the unused minutes. So 15 times 0 is 0, plus 14 times 0, that's 0, plus 20 times 50, that is 1,050 as our X sub 3, plus 0, because we don't have the second slack variable, since T is equal to 0, and that is equal to 1,000. For our third, we have 8 times 0 is 0, plus 6 times 0 is 0, plus 8 times 50, that is 400, plus 400, because we have 400 unused, or the slack, in our third constraint, and that is equal to 800. Now, how do we interpret this result? Shine Company will be able to attain the maximum profit of 2,500 if it will produce 50 of the type C glass windows with unused minutes of 900 in our first department out of that 1,500, and 400 unused minutes out of 800 minutes in our third department. So that's it. So this is our second word problem. Just Eatery sells 3 variations of food packs every day. The first food pack needs 4 hours of cooking and an hour of packaging. The second food pack needs 2 hours of cooking and 2 hours of packaging. The third food pack needs 3 hours of cooking and 2 hours of packaging. They have said that their business labor hours is 1,200 hours for cooking and 750 hours for packaging every 3 months of their production. What is the maximum profit if the food packs produce profits of 8, 10, and 12 respectively for the 3 variations of food packs? Now, for this problem, we will apply the Simplex maximization method in order to determine our maximum profit for this business. So, of course, we have to make our inequality here since we are using the less than symbol for our problem. Now, we have to use variables. First, we'll use variables x sub 1, x sub 2, and x sub 3 to denote our food pack. So, let x sub 1 the number of first variation of food pack, let x sub 2 the number of second variation of food pack, and let x sub 3 the number of third variation of food pack. Now, we have to make our inequality or the mathematical expression for that kind of problem. So first, we have our objective function. This is where we will maximize it. We have to maximize its profit. So z represents our profit. Here, z is equals to 8x sub 1 plus 10x sub 2 plus 12x sub 3. So these are the profits that will be produced by the first, second, and third variation of food packs. Now we have our constraints here. So since we have 2 departments such as the cooking and the packaging, so we have 2 constraints here. So we have to make that inequality. 4x sub 1 plus 2x sub 2 plus 3x sub 3 is less than or equal to 1,200. And for our second constraint, it's x sub 1. It is understandable that for every variable, there is already a whole number 1 for that. So we do not need to put it there. Plus 2x sub 2 plus 2x sub 3 less than or equal to 750. So as you can see in our right-hand side, that is the number of hours that the business have set or allotted in their cooking and in their packaging. And for our left-hand side, those are our variables for our 3 variations of food packs and the number of hours that is needed in order to produce this food pack. So we just have to put it here. And now we will assume that x sub 1, x sub 2, and x sub 3, so the number of first, second, and third variation of food packs are of course greater than or equal to 0 in order to attain that maximum profit. So for our first step, in order to do the simplex method, we have to transform our linear inequality in order to be a linear equation. As you can observe for our mathematical expression earlier, we have used less than or equal simple because that is the case that we are taking here. But we have to make it an equation. So how do we do that? For our objective function, we have to make it equal to 0. So in order for that to happen, we have to transfer right-hand side to the left-hand side, all of our variables and our mathematical expression must be transferred to the left-hand side. So from our right-hand side, we have 8, 10, and 12. So we just have to transfer it. And if you will transfer it, of course, the sign will change. So from its positive sign, we have to change it into negative because it transferred to another side. So it would be negative 8x sub 1 minus 10x sub 2 minus 12x sub 3 plus z, and it is now equal to 0. So for our constraint, how do we do it in order to be equal to an equality 1,500 and 750? We have to add the slack variables. For every less than symbol in maximization method in Simplex, we have to add slack variables. In our slack variables here is represented by the letters T and S. So for our first constraint, it's 4x sub 1 plus 2x sub 2 plus 3x sub 3 plus S. Our S here is our first slack variable, and it is equal to 1,500. For our second constraint, we have to add another second slack variable. So it's x sub 1 plus 2x sub 2 plus 2x sub 3 plus t. Our t here is the second slack variable, and it is now equal to 750. As you can observe, we cannot use the s for our second constraint because it is already used by our first. So we'll have to put the second slack variable. And now we have to initially make our simplex tableau. So just like the first problem, we just have to put all of our equality linear equations in the table. So from our basic variables, we have S, T, and our Z, the slack variables, and the profit. And we just put it there all. The X sub 1, X sub 2, X sub 3, the slack variables S and T, the profit, and our, of course, the right-hand side, the number of hours. So that's 1,200 and 750. So to put it there for our first constraint, it's 4, 2, 3, 1, 0 for our second slack variable because we don't have that for our first constraint, and 0 for our Z. So you can see from our equality, we don't have that. And then for our second constraint, we just have to put it 1, 2, 2, 0 for our first slack variable, but we have 1 for our second slack variable, of course, and 0 for our Z, and it is equal to 750. So put it there. And from our bottom row, we have to put our objective function there. So our X sub 1 is negative 8, X sub 2 is negative 10, X sub 3 is negative 12. We don't have the two slack variables for our objective function. We just have to put 0 here. And for our Z, of course, we have 1 from our equality here. So now we have to perform the pivoting by determining our pivot column, pivot row, and pivot element first. So as what we have done in the first problem, we have to determine the pivot column first. Our pivot column will be observed from our bottom row to observe what is the most negative entry in the bottom row. That is negative 12. So the column where negative 12 is located, that is our pivot column. Now for our pivot row, it will be determined by the smallest positive quotient. So we have to divide right-hand side to X sub 3 because that is our pivot column located. So 1,200 divided by 3, that is equal to 400. 750 divided by 2, that is 375. So as you can observe, what is the smallest positive quotient here? Of course, 375. So that row where 375 is located, that will be now our pivot row. And to determine our pivot element, where the pivot row and the pivot column intersect, that is number 2. So that will be our pivot element. So the pivot element is equal to 2. So we have to make it equal to 1. So to do that, we have to divide it by itself. And the whole pivot row will be affected. So 1 divided by 2, that is 1/2. 2 divided by 2, that is 1. 2 divided by 2 is 1. 0 divided by 2, it's 0. 1 divided by 2, that is 1/2. 0 divided by 2 is 0. And 750 divided by 2, we have 375. So that result will now be our new pivot row as here. So just have to put it here, and we have to determine our entering and leaving variable. So our entering variable is the column where our pivot column is. So that is X sub 3, and our leaving variable is T because it is on the pivot row. So T will be replaced by X sub 3. And now, the most important part is we have to make all the entries in the pivot column to 0. So as you can see, we have 3 and negative 12. So we have to make it 0. So for our first row, 3, we have to make it equal to 0 by adding negative 3. So how do we do that? We have to multiply negative 3 to our pivot row. So negative 3 multiplied by 1/2, that is negative 3 over 2. Negative 3 times 1 is negative 3. Negative 3 times 1 is negative 3. Negative 3 times 0 is 0. Negative 3 times 1/2 is negative 3 over 2. Negative 3 times 0 is 0. Negative 3 times 375, that is negative 1,125. So that result, we have to add it to our previous row 1. So our previous row 1 is 4, 2, 3, 1, 0, 0, 1,200. So to add that, 4 plus negative 3 over 2, we have 5 over 2. 2 plus negative 3, we have negative 1. 3 plus negative 3, we have 0 now. 1 plus 0, that's 1. 0 plus negative 3 over 2, we have negative 3 over 2. 0 plus 0, we have 0. 1,200 plus 1 plus negative 1,125, we have 75, positive 75. So that will be a new row 1, as you can observe in our table. Now we have to make negative 12 equal to 0 by adding positive 12, of course. So we have to do the same process. We have to multiply the pivot row to 12. 12 times 1 over 2, that is 6. 12 times 1 is 12. 12 times 1 is 12. 12 times 0, that's 0. 12 times 1 over 2, or 1 half, that is 6. 12 times 0 is 0. 12 times 375, we have 4,500. So that result, we have to add it from our previous row 3, as you can see. So to add, negative 12 plus 6, we have negative 2. Negative 10 plus positive 12, that is 2. Negative 12 plus positive 12, we have 0. 0 plus 0 is 0. 0 plus 6 is 6. 1 plus 0 is 1. And bring down 4,500. So as you can see, we have to put our new row 3 now in our table. So as you can observe, we already transformed it into 0 except for the pivot element. However, we have to observe now the pivot row in the very bottom row if there is still a negative entry. As you can observe, we still have negative 2 as our negative entry. That means this is not yet the end because we have to do the same process again because we have to maintain that there is no negative entry in our bottom row to obtain the optimal solution. So we have to do the same thing again. So our negative 2, of course, that will be our pivot column where the negative 2 is located. And determine the pivot row. So we have to divide the right-hand side to that pivot column. So 75 divided by 5 over 2, we have 30. 375 divided by 1 half, we have 750. So as you have observed, what is the most smallest positive quotient here? Of course, that is 30 in our row 1. So our row 1 here will be our new pivot row. So to where our pivot column and the pivot row intersect, that is now our pivot element. So now our pivot element is equal to 5 over 2. So we have to make it or maintain it into equal to 1. So to do that, we have to divide it by itself. Now the whole pivot row will be affected to that. So to divide it, 5 over 2. 5 over 2 divided by 5 over 2, that is 1. Negative 1 divided by 5 over 2, that is negative 2 over 5. 0 divided by 5 over 2, that is 0. 1 divided by 5 over 2, that is 2 over 5. Negative 3 over 2 divided by 5 over 2, that is negative 3 over 5. 0 divided by 5 over 2, that is 0. And 75 divided by 5 over 2, that is 30. So that result will now be our new pivot row. So as you can observe, we have 1 as our pivot element. And of course, we have to determine our entering and leaving variable again. So our entering variable will be where the variable in the pivot column is. So that's x sub 1. And our leaving variable is on the pivot column or the pivot row. So as you can observe, that is s. So s will be replaced by x sub 1. And now we have to make all the entries in the pivot column 0 except for our pivot element. So 1 half, we have 1 half. To make it 0, we have to add, of course, negative 1 half. So now we have to multiply negative 1 half to our pivot row. So negative 1 half times 1, that's negative 1 half. Negative 1 half times negative 2 over 5, that is positive 1 over 5. Negative 1 half times 0, that's 0. Negative 1 half times 2 over 5, that is negative 1 over 5. Negative 1 half times negative 3 over 5, that is positive 3 over 10. Negative 1 half times 0, we have 0. Negative 1 half times 30, that is negative 15. So that result, we had to add it to our previous row 2 in order to have that 0 that we are aiming. So 1 half, 1, 1, 0, 1 half, 0, and 375 are the previous row 2. So to add, 1 half plus negative 1 half, we have now the 0. 1 plus 1 over 5, we have 6 over 5. 1 plus 0 is 1. 0 plus negative 1 over 5, we have negative 1 over 5. 1 half plus 3 over 10, that's 4 over 5. 0 plus 0 is 0. 375 plus negative 15. Of course, we have to subtract because they are in unlike signs. So that is 360 and copy the sign of the larger number. So positive 360. So that result will now be, these results will now be our new row 2. As you can observe, we have 0 for our row 2 in the pivot column. Now, we have to make our negative 2, of course, as 0 as well. So, to be able to do that, we have to add positive 2. So, we have to multiply it by 2. So, 2 times 1 is 2. 2 times negative 2 over 5, that is negative 4 over 5. 2 times 0 is 0. 2 times positive 2 over 5, that is 4 over 5. 2 times negative 3 over 5, that is negative 6 over 5. 2 times 0 is 0. 2 times 30, that is 60. So that result, we have to add it to our previous row 3. So now to add, negative 2 plus positive 2, that is 0. 2 plus negative 4 over 5, that is positive 6 over 5. 0 plus 0 is 0. 0 plus 4 over 5, that is 4 over 5. 6 plus negative 6 over 5, we have positive 24 over 5. And 1 plus 0, that is 1. 4,500 plus 60, that is 4,560. So that result now, that will be our new row 3 to be put to our table. Okay? So with that, we have to just put it to the bottom row. So as you can observe, it's 0, 6 over 5, 0, 4 over 5, and 24 over 5, 1, 4,560. So as you can observe, is there any negative entry in the bottom row? Of course, there is no negative entry anymore. And on our pivot column, all of the entries are 0 except for our pivot element, of course. So that means we have obtained the optimal solution. And now we just have to interpret it. So our x sub 1 here is 30. Our x sub 3 here is 360. And our z, or the profit here, is 4,560, looking at the basic variables and the right-hand side. So now we have to interpret it. We have to interpret it. So our x sub 1, as you can observe, that is equal to 30. Our x sub 2, we don't have x sub 2 here in our basic variable, so that is equal to 0. So our x sub 3 is equal to 360. Our two slack variables, as you can observe, we don't have s and t here in our basic variable column, so we don't have it, so that's 0. And our z is 4,560. So we have to substitute it. So 4 times 30, that is x sub 1, plus 2 times 0, because we don't have x sub 2, plus 3 times 360, because our x sub 3 is 360, plus 0, because we don't have the first slack variable, right? So as you can do the math, that is equal to 1,200. So now the second constraint, we have to substitute it. So for our x sub 1, we have 30 plus 2 times 0, because we don't have, again, the x sub 2, plus 2 times 360 as our x sub 3, plus 0, because we don't have the second slack variable. Or we can also not add 0 now, because it is understandable that we don't have value for that variables or slack variables, and that is equal to 750. So how do we interpret this result? So actually, just Eatery can obtain the maximum profit of 4,560 if it will produce 30 of the first variation of food pack, 0 for the second variation of food pack, and 360 for the third variation of food pack with no unused hours, because we don't have slack variables. So all 1,200 hours and 750 hours will be used in order to obtain this maximum profit in their production. So now we are down to our third word problem to really understand how Simplex method is being applied to linear programming problem. So our third word problem is here. Donnie's Car Wash offer car washing services both for motorcycles and cars. It has 100 hours of washing and 80 hours of waxing time available every week. The business charges 400 for motorcycle and 800 for a car. Each motorcycle washing requires 0.5 or 1/2 hours of washing and 1 hour of waxing. And it was estimated that each car requires 2 hours of washing and 2 hours of waxing. What number of motorcycles and cars will bring to the maximum revenue? So we will determine here the number of motorcycles and cars in order to attain that maximum revenue that Donnie's Car Wash can have. So we can also identify here the maximum profit or the maximum revenue by using Simplex method, of course. So we have to use variables for our cars and motorcycles. So let X the number of motorcycles and let Y the number of cars. So we have to make our linear inequality because we are using less than symbol in our case or in our discussion by using simplex method. So our first function or objective function, we have z is equal to 400x plus 800y. So that is the amount of profit that they can obtain in each motorcycles, the x and the y as the car. So that is stated in the problem. And then we have our constraints here. So we have 0.5x plus 2y is less than or equal to 100. That is intended for the washing time. So our cars and motorcycles needs 1.5 hours and 2 hours of washing as stated in the problem. And for our second constraint, we have x as it is understandable. We have a whole number 1 for that variable plus 2y less than or equal to 80. So that is for the waxing time for the motorcycles and cars. And we will assume that x and y is of course greater than or equal to 0. So now we have to make it an equalities from being inequality as less than symbol. So to do that, first for our objective function, we have to transfer the right-hand side to the left-hand side in order to make it equal to 0 now. So as we transfer it, of course, the sign will change. So it will be negative 400x minus 800y plus z, and that is equal to 0. So for our constraint, we have to add, of course, the slack variables again to make it equal or to make it a linear equation now. So for our first constraint, we have 0.5x plus 2y plus s as our first slack variable, and that is now equal to 100. So observe, we have our slack variable here. And then for our second constraint, we have x plus 2y plus t. T represents our second slack variable and it is equal to 80. So now we have to make our, of course, initial simplex tableau. So we just have to put the basic variables, the s, t, and the z, and put all of our equations in the table. So 0.5, we can also use 1/2 for that. So in this table, I have used 1/2 plus 2y plus s as our first slack variable. We have 1 for our constraint, 0 for our second slack variable, and 0 for our z, but we have 100 as our right-hand side, as you can observe. And then for our second constraint, we have 1x because, of course, we have 1 for every variable. And for our y, we have 2. Our s here is 0 because, of course, in our second constraint, we have no s, but we have t. The second slack variable, we have 1. And then for our z, that's 0. And our right-hand side, that is 80. So our bottom row, that is for our profit. So, of course, our x is negative 400, our y is negative 800. We don't have the slack variables in this objective function, so that will be 0. But we have 1 for our z, for our profit here. So that's it. Now we have to perform pivoting now, and by determining our pivot column, pivot row, and our pivot element. So to do that, we have to determine what is the most negative entry in our pivot or in our most bottom row. So of course, that is negative 800. So that column where negative 800 is located, that will be now our pivot column. Now, to determine our pivot row, we have to divide the right-hand side by the pivot column. So 100 divided by 2, that is equal to 50. 80 divided by 2, that is equal to 40. So what is the smallest positive quotient between the two? Of course, that's 40. So the row where 40 is located, that will now be our pivot row. And to determine our pivot element, that is where the pivot column and pivot row intersect. So that is the number 2. So 2 here will be our pivot element. And as I have stated earlier, we have to maintain our pivot element as equal to 1. So to do that, our 2 must be divided by itself. 2 must be divided by 2 in order to have that pivot element of 1. So the whole row will be affected. So 1 divided by 2, we have 1/2. 2 divided by 2, we have 1. 0 divided by 2, we have 0. 1 divided by 2 is 1/2. 0 divided by 2 is 0. 80 divided by 2 is equal to 40. So that will be now our pivot row. So as you can observe, we have 1 as our pivot element. And we have to determine the entering and the leaving variable because it is really important in this method. So the pivot column where y is located, that variable y, that will now be our entering variable. And the leaving variable will be determined in our pivot row. So t is located in our pivot row. So t here will be replaced by the variable y. So we have now that, and now we have to make 2 and negative 800 equal to 0. So in our pivot column, it should be equal to 0, but the 1 or the pivot element must always be 1. So 2 and negative 800 must be equal to 0. By doing that, from our first row, 2, to make it equal to 0, we have to multiply it to the pivot row. Negative 2, because 2 plus negative 2, that will be 0, right? So negative 2 times 1/2, that is negative 2. Negative 2 times 1, that is negative 2. Negative 2 times 0 is 0. Negative 2 times 1/2, that is negative 1. Negative 2 times 0 is 0. Negative 2 times positive 40, that is negative 80. So that result, we have to add it to our previous row 1. So to add that, 1/2 plus negative 1, that is negative 1/2. 2 plus negative 2, we have now the 0. 1 plus 0 is 1. 0 plus negative 1 is negative 1. 0 plus 0 is 0. 100 plus negative 80 is positive 20, because of course you have to subtract it since they have unlike signs and copy the sign of the larger number. So that will be our new row 1. As you can observe, we have 0 now for our pivot column, but negative 800 must be 0 as well. So to make it equal to 0, we have to add positive 800. So to do that, we have to do the multiplication again. 800 times 1/2, that is 400. 800 times 1, that is 800. 800 times 0 is 0. 800 times 1/2, that is 400. 800 times 0 is 0. 800 times 40 is 32,000. Now that result, we have to add it to our previous row 3. So to add that, negative 400 plus 400 is 0. Negative 800 plus positive 800, that is 0. 0 plus 0 is 0. 0 plus 400, that is 400. 1 plus 0, bring down 1. And we have to bring down 32,000. So that will now be that result in the bottom row. That will be our new row 3, or the bottom row. So as you can observe, we just have to put our result in the table. Now, we have to observe the pivot column. There is no other number anymore. We have 0 and the pivot element 1. And we will observe the bottom row if there is still a negative entry. As you can observe, we have 0, 0, 400, 1, and 32,000. We don't have a negative entry there, right? So that means we have achieve our maximum solution for this problem. So the method is done, and now we will just have to interpret it. So our S is equal to 20, looking at our right-hand side, and our Y is equal to 40, and our Z is 32,000. So to interpret that, S is 20, Y is equal to 40. Our X, as you can see from our basic variables, we don't have an X here, right? So that's understandable that it is equal to 0. And our T, for our slack variable, the second one, we don't have it as well, so that's 0. And our profit here is 32,000. So we have to substitute it to determine if it is really an equality. So 1/2 times 0, because our X is 0, plus 2 times 40, as our Y is 40, plus 20, because we have the first slack variable for our first constraint, S, represented by S, so that's 20. So 40 times 2 is 80, plus 20, that is 100. So for our second constraint, 0 for our X, because we don't have an X here, plus 2 times 40, because 40 is our Y, plus 0, because we don't have the second slack variable. The value is 0. So 40 times 2, that is 80. So as you can observe, it is equal. And how do we interpret this result? So to interpret that, the Donny's Car Wash can achieve the maximum profit of 32,000 if it will have the customer of 40 cars, no motorcycles because X is 0, and there will be unused hours or unused 20 for our first department. So that's 20 hours unused out of 100, while 80 will be used, and that's the maximum profit for that. So now, that is the whole method of Simplex maximization method by using the less than symbol. And I hope you have learned something, and thank you for watching it. Goodbye and God bless.